So the average value of the sinusoidal current and voltage was discussed in the previous class, and the result which was found to be 0.637 times the maximum value. So this value is applicable for sinusoidal quantities. It can be your current, voltage, or EMF, whatever it may be. But the thing which is to be taken care of is that this average value is for first half cycle only and not for the full cycle, because the full cycle average value of the full cycle of the sinusoidal quantity will be zero because of the wave shape. The positive wave shape, positive half cycle wave shape is equal to negative half cycle, and it will cancel out each other. Okay. So now RMS value for the sinusoidal current or the voltage, this is the fresh topic which we are beginning today. So this again you have studied in your previous year, sorry, in +2. So this average half cycle of the I square is taken. So I is the instantaneous value of the current. It is Im sine omega t. So we will be squaring this, integrating this, and dividing this by I. Okay, to get the average value. As I have explained you in the previous class also, since if we are calculating the RMS value of any regular function or of a curve whose function is defined, then that can be taken as area under the curve using the integration, definite integral techniques. Okay, so this is Im square sine square uh, d omega t, and cos 2 theta is equal to 2 cos square theta minus 1, or 1 minus 2 sine square theta. That formula is applied here, and integration is done, and division by pi is done, and at the end a root is taken, and the final value of the RMS value of the current is shown as Im by root 2. Okay, so you have to remember this result, Im by root 2. Next is the form factor. Form factor is the ratio of the RMS value to the average value of the periodic wave. Okay, so this is form factor is applicable for the periodic wave. Okay, so it is not only restricted to the sinusoidal quantities. So but if we are taking the sinusoidal values, so we will divide this RMS value by the average value, Em by root 2 upon 2 Em by pi, and the result will be 1.11. Okay, again the thing which is to be taken into consideration is that this form factor is also defined for the positive half cycle. Okay, so next is the peak factor. So peak factor is the ratio between the maximum value and the RMS value. So it is very essential in connection with determine the dielectric strength. Since the dielectric stress developed in any insulating material is proportional to the maximum value of the voltage applied to it. Okay, so this peak factor is having the applications in determining the dielectric strength. So dielectric strength is also known to you because you have studied this as well in your previous class. So it is a previous year in plus 2. uh, so it is also called crest factor and amplitude factor. So when the ratio of the maximum value and the RMS value is taken, it comes out to be 1.414. Okay, because RMS value is nothing but the EM by root 2. So when EM is divided by EM by root 2, this is the maximum value and this is the RMS value. This cuts and it goes up. So its value is 1.414. Okay. So it is having the application in dielectric strength. So what is the dielectric strength? So you can say that if any insulating material, say solid insulating material or liquid or gas, is present between the two electrodes, cathode and anode, but in the experiments which we have studied, the cathode is denoted by K, so you can replace by K as well. So if the liquid or gas is present between these electrodes and this high voltage DC supply is given to it, so dielectric strength denotes the value when the ionization takes place or the electrons start moving from cathode to anode. Okay, so the let us suppose the gas is there or any air is also a gas, so it is present here. So when the it can be considered as a variable high voltage supply. So as and when this voltage supply is increased gradually, the electrons will start moving, ionization will take place and electron will start moving from cathode to anode. Okay, so one thing is that it is depending upon the voltage. Now the formula of the dielectric strength which you have studied in your class 12th is kilovolts per centimeter. Okay, it can be centimeter, it can be millimeter, it is the distance unit. Similarly, this can be the voltage unit, it can be kilovolts, megavolts, etc. So either the voltage is to be increased to get the ionization, or the distance between these electrodes is to be reduced. So if the distance is reduced, say the anode is here instead of earlier, so now the electrons can reach easily. Okay, so the dielectric strength is inversely proportional to the distance between the electrodes and directly proportional to the magnitude of the high voltage applied. Okay, so since the maximum voltage is taken into consideration, so this peak factor is helpful here. Okay, so consider this a half rectified AC wave as shown. So if we are required to calculate the form factor and peak factor of this wave, we can calculate. So the wave shape of the periodic curve can be different. Okay, so based on those function, the peak wave peak factor and form factor can be calculated using the RMS and average values. Okay. Wave shape can be different for different condition. Suppose that wave shape can be, instead of beginning with the zero value, it can begin with, say, any, say if it is current wave or voltage wave, let us suppose it is voltage wave and it is 20 volts. Okay, and its peak value is again say 20. So Im sin Vm sin omega t, or Vm is replaced by 20, so 20 sin omega t is the wave shape of wave function of this, but at every point it is added by 20 volts. Okay, so the instantaneous voltage or instantaneous value of such kind of the wave will be 20 plus 20 sine omega t. Okay, so if we are required to calculate the average value, now the function is known to us. Once the function is known to us, formulas are known to us, we can apply the average value, RMS value, and so on to get the results. Okay. Similarly, the wave shape can be triangular, say right angled triangle. It can be equilateral triangle as well. It can be like this. It can be positive and negative half cycle both. It can have the trapezoidal shape as well. So any trigonometric shape it can take, but the process remains same. Okay. Once we will be doing these numericals based on this theory, those things will be more clear. At present, you have to focus that depending upon the shape, first of all, function is calculated, and after that, formulas are applied to calculate the RMS and average values, and then we go for the peak factor and the form factor calculation. Okay. So consider this half rectified AC wave. So in the second half cycle, it is zero. Okay. So if now we are calculating the average value for full cycle, what difference it will make? Current wave shape is same. So I square d theta. So sinusoidal waves can be defined using theta values as well as using omega t values. Okay, so we should be comfortable with both the situations. Okay, so this is I square d theta, and if we replace this I by Im sin omega t and then integrating it, but since we are calculating the RMS value and average value for full cycle, so we are going to divide it by 2 pi instead of pi. Okay, so rest of the result is same. So RMS value was earlier Im by root 2, but now since this is 2 factor which is under root, so this 2 and 2 becomes root 2 was earlier, now root 2 is there, so it is multiplying to get the result of RMS value as Im by 2. Similarly, for the positive half cycle, the average value of the sinusoidal wave for the positive half cycle was 2 Im by pi. But now since we are taking full cycle, so this 2 factor is there, so denominator 2 factor and numerator will cut each other. Now this average value is this, okay, Im by pi. So if we are required to calculate the peak factor, that is Im by Irms, so it will, it comes out to be 2, and form factor is Irms upon I average. So dividing these values, we get the result as 1.57. Okay, is this clear to you, everyone?
Yes, sir.
So, so the next topic is the phasor. So we come across this phasor many times, but what is actual meaning of this phasor should be known to us. First of all, we should consider one thing, that while we are studying the single phase AC circuits, we are dealing with the sinusoidal quantities, and the sinusoidal quantities completes is its one cycle in 2 pi radians or 360 degrees. Okay, so there is a similarity between the 2 pi radians, the time period of the sinusoidal quantity, with the circular completion of any point. Okay, because we know that if a point is in anti-clockwise direction, is rotating in the anti-clockwise direction, and after the completion of one full circle, the total angle traveled by that point is 2 pi radians or 360 degrees. So we use this similarity to our benefit. So if we are connecting this point to the center of the circle, an imaginary rotating line is received. So this imaginary rotating line is called phasor. Okay. So if a sinusoidal quantity, voltage or current, is represented by the line of a definite length rotating in anti-clockwise direction with the angular velocity as that of sinusoidal quantity, then the such rotating line is called phasor. Okay. So what is to be taken into account? First is the anti-clockwise direction, as the anti-clockwise direction is also the positive direction of x-axis. Second is the angular velocity of such a rotor should be same as that of the sinusoidal quantity. Only then we can relate them. So how can we relate them? What benefit do we get from it? Is that the instantaneous value of any sinusoidal quantity. Let us consider in this case our EMF. So instantaneous quantity of the EMF can be calculated. For example, let us suppose that the theta angle has been passed, or you can say that omega t radians have been passed from the initial position, say t is equal to 0. Okay, so at this theta is equal to omega t. The magnitude of the instantaneous current is E, and same vertical distance can be measured from this circle. Okay, so it gives the instantaneous value. Another, you can say that this is the EM, maximum value of the EMF, and this is also maximum. So the radius of that rotating line, or you can say the modulus of the that rotating line, is equal to the maximum EMF, magnitude of the maximum EMF. Okay, so now what is phase? So by phase of a alternating current, whenever we talk of this alternating current, it means that it can be any alternating quantity. Okay, voltage, current, or EMF. Okay, so it is meant that is fractional of the time period of that alternating current that has elapsed or passed, since the current has passed through the zero position of the reference or the reference axis. Okay, so it represents the time period which has been passed. Okay, because x-axis can be represented by time t, or theta in degrees, or omega t in radians. Okay, so in phase we are concerned with the time period. Okay, now it is the phase angle. So it is the angle which is made by this phasor with the reference line, or 0 degrees, or radians, or you can say x-axis. Now is the phase difference. So whenever we are taking two sinusoidal quantities and comparing them, okay, so there will be some angular difference or no difference, but if at all there is some angular difference, then that is called phase difference. Okay, so if the it is the angular distance measured in degrees or radians between the points where the two curves cross the base or the reference line in the same direction. Okay, so if the I1 and I2 are the two quantities and they are having phase difference theta or phi, it means that, suppose that I1 is at 0 and I2 current reach the 0 value after the phi angle has passed. So we can say that I1 is leading the I2 by phi, or we can say that I2 is lagging I1 by phi. Okay, so it is just the difference in the angle. Here we are not talking about the magnitude or the amplitude. It can be same, it can be different. It is not going to affect the angular difference. Okay, so if I1 is equal to I1m sine omega t, and I2 is I2m sine omega t minus phi, because its angular difference is minus phi. Okay, so it is just for your convenience that these magnitudes are drawn in a say more or less same amplitude, but it can be different. Okay, suppose this is the I1 and I2 magnitude I2 is lagging by 5. So it can be less than, so it's zero crossing, it will reach the, this say this is the maximum value. So it will reach the maximum value after 5 has been passed. Okay. So let us suppose that this is its 5 value. So again it's zero crossing will be after 5 angle. Okay. So at every stage it will be lagging by 5. So the diagram which I have just drawn, this show the I2 value. Here I have deliberately drawn its amplitude which is less than the I1. Okay, clear? But as I have just mentioned that it has nothing to do with the amplitude. It can be less or it can be more. Okay, for example, if this is I1, okay, and we are required to draw the I2. So let us suppose this, it has started after 5 angle and it reaches its maximum. So again this I2 is also equally good because the phase difference just shows the phase angle difference and not the amplitude. Okay, and this phase difference can be among the similar quantities, say current I1 and I2, or it can be between the current and voltage or current and EMF. Okay, so this is the diagram which we have shown, and this is the phasor diagram. So what is the difference between the diagram waveform or the phasor diagram? There are few differences. First of all, direction is shown in the phasor diagram as shown here in the anti-clockwise diagram. Secondly, its vertex is shown by the capital letters. So as we have denoted by this capital A, either it can be done in this manner or we can simply denote the this alternating quantity in a capital letter mode, say I1, I2. Okay. So generally these waveforms denote the instantaneous values and these phasor diagram denote the RMS values. Hence it is written by the capital letters. And also it is written in a bold, but since we are writing with our pen and pencil, so every time it is not possible to denote this in bold letter. So but the capital letter is to be taken care of. Okay, so next is in phase. So what does in phase means? That the two sinusoidal quantities do not have any phase difference, which means that the zero crossing of these alternating quantities, be it a current voltage, will be same. They will cross the zero axis or the reference axis or the x-axis simultaneously. Okay, and they will rise in the same direction. Okay, so their direction is also same. Phasor diagram is shown here. So its phasor diagram is denoted by capital letters. Okay, A, say B. So both are shown parallel to x-axis. This is, it signifies that there is no phase difference between them, and A and B are in capital, or you can replace by I1 I2 in capital, all the same. Okay, now it is the phase opposition. So what is the phase opposition? Phase opposition denotes that the both the sinusoidal quantity will pass through zero at the same instant. That is fine, but they will rise in the opposite directions. Oh, okay. So which means that the phase difference between them will be 180 degrees. Okay. So let us suppose that these I1 and I2 are the two sinusoidal quantities. So one is rising from zero value and completing its first half cycle at 180. Second wave will start from 180. Okay, so it means that there is a phase difference of pi radians or 180 degrees. Okay, so it can be also said they are rising in the opposite directions, because as this I1 is rising in downward direction from 180 to 360, this I2 is rising in the positive direction. So that's why you can say that they are rising in the opposite direction. Now, what about their phasor diagram? So their phasor diagram is shown here. So I1 and I2 both are at zero at a particular time, but one is rising above and their direction is also same. That is also good. But one direction of rotation is same. That is anti-clockwise direction. But one is rising from zero to maximum positive value and other is decreasing from zero to maximum value. So here lies the difference. Okay. Similarly, if the two alternating quantities differ by pi by 2, they are said to be in quadrature. Okay. You know very well quadrilateral. So what is quadrilateral? Which is having four sides. Quad means four. Okay. Quadcopter you have seen. Okay. So whenever this quad word appears, it means four. And since these 360 degrees can be divided in four equal parts, so these two alternating quantities which are having the difference of 90 degrees or pi by 2 radian, they are said to be in quadrature. Okay. So if there are series circuits, then the phasor quantities, in the phasor quantities, x-axis is generally taken as reference, but in parallel circuits, it is generally voltage phasor, and vertical and voltage phasor is drawn as a horizontal line and taken as reference phasor. Okay, it is just for a reference, but it may not be followed strictly. That's why it is written that it is usually taken, or it is generally taken as this. Okay,